When analyzing recursive algorithms, we get recurrence relations as time complexity equations. Recurrence relations are equations that define problem in terms of small instances of itself. Like T of n is defined in terms of T of n minus 1, or T of n is defined in terms of T of n by 2. Now, how to solve those problems to find the final time complexity? To solve those, we will be using one of the methods called repeated substitution method. In repeated substitution method, you keep expanding the recursion step until a pattern found. Once you find a pattern, you find out the number of steps required to reach to a base case, and from that we can get the solution to the equation. So let us consider examples to understand that. So consider the first equation. T of n is 2 into T of n minus 1 plus c. This is the recurrence relation that we get when we analyze the time complexity of towers of Hanover problem. The number of moves required to move n disk from tower A to tower B by using an intermediate tower C. Now to solve this recurrence relation, first we consider what is T of n minus 1. So from this equation, we can say if you substitute in place of n minus 1, we get T of n minus 1 as 2 into T of n minus 2 plus C. So C is an independent value which does not depend on n, so we'll get this. And now substitute T of n minus 1 into the original equation. So if you substitute, then T of n as 2 into 2 of T n minus 2 plus C, then we'll get 2 square T of n minus 2 plus 2C plus C. Now again consider what is T of n minus 2. From the original equation, we can say T of n minus 2 as 2 into T of n minus 3 plus C. Substitute T n minus 2 into the above equation. Then we will get T of n as 2 cube T of n minus 3 plus 2 square C plus 2C plus C. So after doing two substitutions, we can clearly see a pattern. When we do k times the same substitution, we get 2 power k into T of n minus k, because 2, 3, T n minus 3, so 2. And this is C into 1 plus 2 plus 2 square. So we will get 1 plus 2 plus 2 square, so on up to 2 power k minus 1. That means we found a pattern. Once we found a pattern, next step is we have to identify when it will reach to a base case. For what value of n it reaches to a base case from this, or what value of k it reaches to the base case. Now if you substitute k as, or when we k as n minus 1, or if you substitute n minus k equal to 1, that is the time it reaches to a base case. So we get k as n minus 1, and if you substitute there T of n as 2 power n minus 1 plus C into the summation 1 plus 2 power 0, sorry, 1 plus 2 power 1 plus 2 square, so on up to 2 power k minus 1. That can be written as 2 power k minus 1 by 2 minus 1. So here k is n minus 1, so you will get C into 2 power n minus 1. So it's in the order of 2 power n. So the time complexity is order of 2 power n. Now let us consider the second problem, where we have T of n is 2 into T of n by 2 plus Cn. So the same method, we have to expand this recurrence until we find some pattern, and then next step is we have to uh, find out when it reaches to the base case. So let us consider this equation, and then uh, what is Tn by 2 from this equation? Tn by 2 is 2 into Tn by 4 plus Cn by 2. Substitute this into the original equation. To substitute into the original equation, then we'll get 2, 2 into Cn plus 2 square into T of n by 4. Now what is Tn by 4 from the original equation? Tn by 4 is 2 into Tn by 8 plus Cn by 4. Substitute Tn by 4 into the above equation. Then we'll get T of n as 3 into Cn plus 2 cube Tn by 8. Now clearly we can see a pattern. If you do it k times, we'll get k into Cn plus 2 power k Tn by 2 power k. Okay. Now we have found a pattern. Now for what value of k it reaches to the base case, that is n equal to 1. If I take n as 2 power k, n as 2 power k, so it reaches to the base case. Now from that k is log n base 2. So we can say this is the first term is c into n log n base 2, and the second term is 2 power log n base 2, that is 2 will cancel out n. So from that we can say that the time complexity is order of n log n. First term is n log n and the second term is n, so we can say n log n. And let us consider another example where we have T of n is 5 into Tn by 4 plus Cn square. So the same method, we keep expanding this recurrence until we find a pattern. Once we found a pattern, we have to see when it reaches to a base case. So what is Tn by 4? Tn by 4 is 5 into Tn by 16 plus Cn by 4 whole square. If you substitute this into the original equation, then we'll get T of n as Cn square plus 5 by 16 into Cn square plus 5 square into T of n by 16. Now again, what is Tn by 16 from the original equation? Tn by 16 is 5 into Tn by 16 into 4, that is n by 64 plus C into n by 16 whole square. Now if you substitute this into the original equation, we'll get T of n as Cn square plus 5 by 16 n square plus 5 by 16 whole square into Cn square plus 5 cube into Tn by 64. Now clearly we can see that there is a pattern. If you substitute k times, then we'll get 5 power k into Tn by 4 power k plus Cn square into 1 by 5 1 plus 5 by 16 plus 5 by 16 whole square, so on up to 5 by 16 whole power k minus 1. Now we have to find sum of this GP series. So sum of this GP series gives you, because 5 by 16 is less than 1, it gives you 1 by 1 minus r, that is 11 by 16. And if you consider, 16 by 11, and if you consider from that you get the first term as order of n square. If you consider n as 4 power k, that is where it reaches to a base case. Now it will be 5 power log n base 4 that can be written from the logarithm equalities as n power log 5 base 4. So you will get n power 1.16, and there are two terms. First term is giving order of n square and the second term is giving order of n power 1.16, and the time complexity is order of n square. We consider higher order term. Okay, and so the homework questions are T of n is equal to T of n minus 1 plus n. T of n is 3 into 10 by 3 plus n, and assume that n is power of 3. And another one is T of n is T n by 2 plus log n. Assume that n is power of 2. So the conclusion is we keep expanding the recurrence step until we find some pattern. Once we find a pattern, we have to see for what value of k it reaches to a base case. Once we get a base case, that base case is either 1 or 0, so we can get the solution to that recurrence relation. Thank you.